So in our last target, we talked about charges, and we talked about whether charges will attract or repel. We talked about Coulomb's law and the force between two charged particles. Now we're going to go ahead and we are going to talk about electric field. So electric field is kind of an abstract concept, but we'll talk about electric fields. We'll talk about how we represent them and how we calculate the strength of an electric field at some point around a charge. So our target is to be able to describe electric fields. So let's go ahead and let's talk about electric fields. The space around a charge where electric forces can act is what we call an electric field, right? Electric fields transfer electric forces. And usually when we represent electric fields, we'll represent them as a kind of series of arrows around a charge, right? So if you look at the picture I have up here, you can see a positive charge and a negative charge. And the arrows represent the electric field, right? You can see with just a single charge, the arrows just go straight out from the charge in each direction. Also notice that for a positive charge, electric field lines travel away from the charge. And for a negative charge, they point towards the charge. When we have a strong electric field, we represent that with many lines, many arrows coming from the charge or going to the charge. And when we have a weaker electric field, we'll represent that with fewer arrows, fewer lines going towards or away from the charge, right? We can also kind of describe what it looks like when the electric fields from two different charges interact with each other. You can see in this picture here, there's a positive charge and a negative charge. And so the electric field lines will move away from the positive charge out in every direction, and they'll move towards the negative charge from every direction. You can see they make a little pattern there as they go between the two charges. So, you can look between the charges and the arrows go straight from the positive to the negative. And as you get, further away, they make these bigger and bigger loops, right? We could also look at what it would look like between two similarly charged particles, between two positives or between two negatives. And I'll leave you to think about what that's going to look like. Okay, we can calculate the strength of an electric field using the equation here. You see it says E equals F over Q. E, the capital E, stands for the electric field strength. And electric field strength will be measured in newtons per coulomb, which makes a lot of sense if you look at the equation because it's got force over charge, right? Force is in newtons, charge is in coulombs. So the electric field strength will be in newtons per coulombs. That's N/C, newtons per coulomb. That's the electric field strength. And we can solve problems using this equation, E equals F over Q. Let's say we have a problem like this. It says an electric field has a strength of 4.0 newtons per coulomb. If the electric force on a charge is 6.43 newtons, what's the charge? So let's write down what we know and what we want to find out. And let's do the math here. So it tells me that the electric field strength is, let's see, what did it say? So the electric field strength is 4.0 newtons per coulomb. It also said that the electric force was 6.43 newtons. And it wants me to find the charge. So it says, find Q, the charge. Okay. We just learned that the electric field strength is the force divided by the charge. So if we put those numbers in there and solve the equation, then we'll find the answer. So E was 4.0, F was 6.43, and Q, we don't know. So to solve this equation, I'm going to multiply Q to the other side, and I'm going to divide 4.0 to the other side. So Q, 6.43 divided by 4.0. I'll get my calculator and figure out what that is. And I'm going to need two significant figures in this answer. I'm going to write, let's see if I can squeeze it in down here. That's two significant figures because 4.0 had two significant figures, so I'll put 1.6. And then what unit do we use for a charge? We use coulombs. So there is how you calculate the strength of an electric field, and there's how you solve a problem using that equation. So there is a little bit about how we represent electric fields using electric field lines, and how we can calculate the strength of an electric field at some point in space around a charge. So hopefully that helps us to be able to represent electric fields or describe electric fields. So until next time, take it easy.